Hello, hello everybody. Good afternoon, good evening to east of Greenwich, and good morning to west of Greenwich. And we have blend of speakers here from operators from Shell, Total, Chevron, and mix of digital uh, service companies too, Binu and Krishna. So thanks for the introduction, Adam. Again, I'm a data scientist for Chevron, and I'm moderating this panel discussions today. And I will let the speakers introduce themselves. Let's start with Andrea.
Sure. Good morning, good afternoon, everyone. So I'm Andrea Kors. I work as a venture principal for Shell. What that means is I work for the venture capital arm of Shell. I specialize in investments in the digital space, which includes the topics we're going to be talking about today, which are IoT, machine learning, AI, and blockchain. So I focus on all of them with a kind of like a lens on energy transition. So I'm looking forward to having the conversation with the other panelists.
Thank you, Andrea. And we have Pedro here, a senior panelist here, I guess. He has been here last year too in this conference. Go ahead, Pedro.
Hi everyone, good morning, good afternoon. I'm the lead data scientist with Total Energies here in the UK. I work in a team called Digital and Data, which is a team that is really tasked with pushing the boundaries of what's possible with data that comes directly from equipment, also from IoT devices. So looking forward to talk about what we are trying to do here and also to learn from everyone. Thank you.
Thank you, Pedro. And here we have Farzad, my colleague from Chevron. Go ahead, Farzad.
Hey everybody, Farzad Sanavala here from Chevron Corporation. Have a background in petroleum engineering, transitioned my career into kind of a digital product manager role. So leading digital solutions across the value chain from the well, surface facilities, supply chain, and now going into the lower carbon kind of digital construct. So I have a huge passion for blockchain and digital twins, been doing a lot of that in my day job. And yeah, really happy to be here with my panelists.
Thank you, Farzad. Binu. Floor is
Thank you,
yours, Binu.
Mustafa.
Yeah.
Thank you, Mustafa. I'm absolutely glad to be on this panel. I'm the Chief Technology Officer and General Manager for Oil and Gas at C3AI. C3AI, together with our partner Baker Hughes, is laser focused on providing business value at scale through enterprise AI. And we do this through providing scaled AI applications, both in terms of scaling our customers' applications. For instance, at Shell and Lyondell, we have deployed very large applications, tens of thousands of models, multiple facilities. We have several of our own applications as well, including reliability, process optimization, supply chain, and more. Very much looking forward to this conversation.
Thank you, Binu. Go ahead, Krishna.
Thank you. Good morning, everyone. This is Krishna. My name is Krishna Bayana. I am CEO and CTO and come hands-on architect on the digital space, digital twins technologies. Blockchain, we are blockchain developer company and we started in 2016, but we are expanding ourselves to the other technologies as well, including IoT, and we just partnered with the Metaverse for the building virtual land. We have offshore team back in India.
Thank you. Thank you all for introduction. As you guys see, we have plenty of people from oil and gas who are digital savvies. Before we start, I would like to remind that you please go ahead and ask questions to the participants in the live conference content here. I will be able to see it, and I will be able to basically forward your questions to our speakers here. And with that, we have a bunch of topics to be covering today, and we have a startup warm-up question here: how a digital twin supports predictive maintenance in reducing downtime. I think this is one of the hot topics, especially in operations for oil and gas. Andrea, you want to start? Please feel free to give
Sure.
your examples if possible too. Yeah.
So
Oh, thank
maybe
you.
from my end, and I don't know if anyone wants to go first, but from my end, yes, maintenance and operations and reducing downtime, it's an application for digital twin that we have been using for a lot of time. Like Shell, at Shell, we analyze more than 10 million data points every minute on equipment like pumps and furnaces to improve their performance. And we have seen that this leads to a more stable operations and greater energy efficiency. Um, but we want to make sure that we are not just focused on maintenance and operations today. Maybe I will start by stating the obvious and taking it a bit on the energy challenge that we're facing, right? So the global population is going to increase roughly to about 9 billion by 2050, which means that the global energy demand will increase by around 100%, right? And more people are going to be living in cities, and more people are going to be expecting the same sort of standard living that we have here in the West. I think without digital twin, digital technologies, we cannot thrive through this transition. So I think it's important to look at operations, but also to look at how it helps the low carbon energy and how these are really important tools to improve the energy efficiency, both for Shell and for our customers.
Thank you. Pedro, do you have things to say too?
A lot of focus on our side on predictive maintenance, really. I would say that digital twins are the things that are really enabling predictive maintenance, real predictive maintenance for the first time here. So instead of over-servicing, over-maintaining the products, to avoid costly downtime, repairs, and or replacements. So it's this ability that of doing just-in-time maintenance to address any performance issues predicted by the digital twin. So having this ability to visualize exactly when and where the maintenance is needed instead of making blind guesses, safe bets. Costly unplanned downtime is then replaced by less expensive maintenance during scheduled set shutdowns that are, of course, cheaper than unplanned shutdowns. So as I'm saying, the costs, the time and cost savings are very substantial, and of course, having the smart connected devices and technologies, which are durable, are cheap. These mounted on top of the machines and other devices. To me, it's this technology is something that has clearly arrived, and we are just really touching the tip of the iceberg on what can be done with it.
Yeah. Thank you, Pedro. Farzad?
Yeah, sure. So I'll kind of break this question kind of into two parts, talking about kind of the efficacy of digital twins and kind of why it's really so important, and then ultimately its impact on predictive maintenance and kind of an engineering domain. So if I were to recap, the definition, I'm sure everyone knows what a digital twin is, but the dynamic kind of virtual modeling of the physical world, enabling our ability to understand, learn, and resist from changes in a physical built environment. Digital twins are really that foundation of smart applications and that continuous kind of real-time capturing of data to optimize performance, predict failures, and simulate and forecast certain scenarios. And so, kind of from a history perspective, we saw the concept of digital twins pioneered by NASA like in the 60s using mirrored systems for the Apollo 13 mission. Then you get the computer and physics-based simulations like Flight Simulator, a game I used to love playing as a kid, and then AutoCAD, something I think a lot of engineers use, well, I don't know about today, but definitely use in their career. And then the official definition of a digital twin by Dr. Greaves in 2002. And so now we're starting to enter the world of, the metaverse, as Krishna mentioned, and Web 3.0. And if you don't enable digital twins for your enterprise, or incorporate it into your digital strategy, there's a very good chance you're going to get left behind. And so when we talk about predictive maintenance, so kind of from a core engineering domain perspective, you kind of have, I like to describe it as the general asset performance management pyramid. You kind of have that, reactive maintenance kind of on the bottom layer. Then you have the preventative and condition-based, and then I think it's predictive. And I think some people even say there's risk based on top. But for the sake of predictive maintenance, why I think that's so important is because particularly in the energy industry, we use a lot of old machinery from compressors, valves, pumps, things that have been designed and have a really valid good use. But the evolution of the hardware technology hasn't changed much. Its core fundamentals are still there. And so with that being said, inspection and maintenance activities are really essential to keep our operations running. And so using reactive maintenance, the kind of old fashioned way of doing things, doesn't really guarantee against any unplanned downtime. And so in some cases, I know in deep water Gulf of Mexico, unplanned downtime can cost you multi-million dollars, tens of millions of dollars in non-productive time or essentially sunk cost. And so that's why predictive maintenance via digital twin technology is so important. Being able to really aggregate vast amounts of real-time data, whether it's Pi or WITS-ML, pretty much anything from IoT sensors, and converging that with AI and cutting-edge machine learning models to predict a certain equipment failure, has not only just a reduction in unplanned downtime, but you see benefits like higher returns, increased workplace safety, and then, of course, operational efficiency, as mentioned earlier. So definitely the implementation of digital twins has a very, very crucial impact on implementing predictive maintenance procedures.
Thank you, Farzad. So, Bino, do you have anything to share and give examples, maybe possible?
Yeah, so I think Farzad, Pedro, and Andrea covered a number of extremely valid topics. I think predictive maintenance is in the enterprise AI space. Digital twins is one of our more mature technologies now. This has moved really from the realm of R&D and into full-blown large-scale deployment. Shell, for example, echoing what Andrea is saying, is dealing with millions of data points a minute. When you look at if you really want to get the sort of scale efficiencies that Farzad talked about, you need to move beyond just the individual digital twins and really deal with this at scale. So for example, if you're talking about data coming in from OSI Pi at the level of scale that you're dealing with, it cannot simply be a web connection into OSI Pi. How do you pull in data, historical data from historians, from backups, without dealing with, without causing any kind of impact to the mission critical systems? How do you model tens of thousands of models? And by the way, Shell actually has that kind of level of production live. Over 10,000 control valves, hundreds, thousands of compressors. Dealing with all of that requires an infrastructure where you can pull in all of this data, get a unified view of it across all of your facilities, build almost on a self-service basis individual models, and then very importantly, make sure you can actually translate that insight into applications that are usable by end users. Which means that at that kind of scale, you also need to think about procedures to ensure that alerts are being reviewed, processed, the appropriate filtered results are being sent to site engineers. So you really need to think about all of that end to end. And the good thing is that this is now actually happening. So Shell, that's very much in place. We do that with LyondellBasell as well. We see that with Koch Industries. But the good thing about this is that combination of technologies is now very much mature and moving into production. And I think it's a harbinger of things that will come for other parts of capabilities that we can now move into in the industry.
Thank you, Bino, for sharing this experiences. And lastly, Krishna, do you have anything to share?
Yeah, definitely. So, I mean, my point here is, the mention here is, in order to achieve whatever we've discussed so far for the predictive maintenance. Of course, AI is one of the technology, but we cannot achieve that only with AI technology. We need to combine. We have to have multiple technologies. So we are working on the several initiatives on the predictive maintenance using AI combined with the blockchain, IoT. These are the one of the recently we developed along with the one of the oil and gas industry expert, and showing the capturing the information and integrating with the cloud and capturing the data using AI. So predictive maintenance for particularly for the asset management is key here, where we need to take the proactive measurements on the offshore particularly in order to avoid the downtime of the operations. And for the service engineering company, they don't have to wait for somebody to report what is going on the asset. He has to get the notification from the particularly blockchain is a key that will notify between the multi parties who are involved in these operations, including the manufacturer, including the service company and the operator, and you will notify this equipment is so many years old, and this is going to, based upon the last 6 months performance, this equipment will go might turn down, switch off, have an issue, then you will notify that. So it's multiple technologies we need to mix. And predictive metaverse right now is the digital twins along with the VR, AR, mixed reality combined with the Web3 technologies is very, very effective in order to improve the efficiency.
Thank you, Krishna.
We had,
Um,
yeah.
yeah, so great points all. And we have a question from the participants too, I guess. The participant asking one challenge he anticipates with predictive maintenance is related to what Pedro mentioned. If you are trying to avoid unscheduled downtime, because it is more cost effective to complete maintenance during scheduled downtime, is there a risk that just-in-time maintenance for multiple assets mean that many will need to be maintained on uncoordinated schedules? I think it's a comment and question a little bit. Who wants to take? Go ahead.
I can provide a perspective on that. It's
Yeah.
something we've actually dealt with. I think the key thing here is that you need to look at both unplanned downtime and scheduled downtime holistically. The beauty of having digital twins models that can predict when you're about to have failures gives you two benefits. One, it gives you some headroom to know that something is going to happen. We're not necessarily trying to push things out of scheduled maintenance. What you're trying to do is get notified if something is likely to happen, and then you can take mitigating steps to prevent downtime, and ideally then put it into a scheduled maintenance window. So it actually does, help with both. It helps you head off any potential unplanned downtime. And this feedback actually can then all go into your planning for schedule optimization. So some of the things that we're doing right now around turnaround optimization really takes the information about risk that has been coming from what you can track with models across individual pieces of equipment. And then based on that, you might actually bring something up in the schedule for scheduled maintenance. And you can otherwise also determine that certain items are just fine and you don't need to deal with that during scheduled maintenance. So you do have the ability to both optimize the scope of turnaround as well as really compress the schedule as well.
Great
Well
point.
said.
So yeah, I guess anomaly detection has been utilized for operations and for downstream, upstream, doesn't matter, for oil and gas for a lot of time. And as you guys mentioned, so but with Chevron, we have been experiencing a lot of downtime issues, and we build machine learning models to detect anomalies ahead of time and inform our operators. With those models, we not only prevent unplanned shutdowns, but also it was giving the confidence to the operators to get a higher rates because they have previous indication, they have the health monitor of a well that they can take actions. So with that, I would like to go to next discussion topic. Let me quickly check if we have a QA. We don't have a question on this topic. So now we are going to include blockchain in our discussion, ensuring safe and secure data with blockchain. How can digital twins innovate faster through this integration? Who wants to start first?
I can start.
Okay, Pedro.
Yes, I think it's good to set the scene here in terms of like two main parts in my view that where the interaction happens. So between the digital twins and blockchain. So if we want to make sure that the information around the twin is immutable, meaning that it cannot be changed. So from a compliance, if you want a regulatory point of view, I need to show that the decisions that are made by the twin are safe, and I need to go then and prove it later on. So instead of storing it on a conventional database, one of the ways to store this digital twin and the information is the blockchain. So, and also, of course, with that comes with validating where the data sources come from. So that's kind of the first part within the digital twin. And then another major area is then for blockchains and digital twin is when we want the digital twin to interact. What I mean by that is one of the big cases for distributed ledger is around the smart contracts, of course. So if you want that digital twin to interact on our behalf when it receives certain information, when certain conditions are true, on when certain events have happened, we want then a smart contract to be executed. So we can put that into the digital twin as well. And in fact, we can combine also going one step further, machine learning so that it can predict that something will happen and based on that initiate a payment in a smart contract for someone to go or any other sort of message being passed through and deliver some services or pass some data through. All that can be built into the digital twin using the technologies from blockchain. So I thought that it will be good to divide between these two, and I'm really looking forward to understand if the other panelists also think that these are separate things, but they need to work together.
Thank you, Pedro.
Yeah. No, that
Andrea.
was really good, Pedro, and I think you did a really good job. I would say that the way that we look at digital twins at Shell, it's we break them into 3 dimensions. So you have the data part, which is the time series data, the maintenance data, the PNIDs. You have the modeling part, where you would have your predictive analytics and your maintenance modeling. And then the third layer is the visualization, right? Whereas where you have your 2D or 3D or AR, VR applications. I think blockchain could be used definitely in the data part to ensure that the data that's going into these models has actually been, like you mentioned, that it is immutable and that it is transparent and that it has that kind of like security seal to it. So we ensure that we're getting the right data and that the data is not changing. Um, on the modeling side and on the smart contract, I think for me that's a bit more futuristic or still a further down milestone. But I definitely think when it comes to the data, blockchain would be a great tool to use for digital twins.
So I could go next and kind of play the, not necessarily devil's advocate, but kind of my take on blockchain, its integration with digital twins. So to answer if it helps us innovate digital twins faster, I don't necessarily think that that's a fair statement. And so the reason why is, or I guess let's first talk about blockchain. So blockchain is, essentially the cryptographically secured chain of blocks. So blockchain is a very back-end like technology. And so it's pretty much, I say, anytime there's an issue between multiple different entities or parties, and there's an issue of quote unquote trust, then you throw blockchain into the conversation. Otherwise, if you don't need a shared ownership of your data, whether that's whatever type of data, real-time streaming data, transactional data, financial data, whatever it may be, if you don't need a shared ownership of it, blockchain may be overkill, and it may be from an IT resourcing and infrastructure and even cloud operating cost perspectives, you're adding a lot more than you really actually need. So for digital technologies deployed in the context of the energy industry, in order for it to work to everyone, you need to enable individuals to, scrutinize their outputs and methods, and they have to be secure and resilient, which is another really important I guess, pro of using blockchain technology. And you need kind of that wide engagement of all your different stakeholders. You talk about your proof of stake, your proof of work, consensus mechanisms within the blockchain construct. And so on the pro side of blockchain, it will significantly improve your transparency, your accountability. You talked about immutability and traceability, and give you perhaps more accurate, reliable, standardized, maybe even through a smart contract, a solidified data model that, hey, if these parameters don't fit, this unit or this column or this unit of measurement or something like that, it could reject it in the system. So you get that sort of smart contract logic, particularly when you're transacting between two different parties. But for something inside of a single operator, for example, it might be overkill to implement a blockchain solution for, let's just say, an internal business software application. And so that's kind of my rule of thumb and kind of my lesson learned going throughout my blockchain journey over the past few years is talk about, I ask these questions to myself. Do I need a shared consistent data store? Do I need more than one entity or enterprise in this situation or vendor to contribute data? Are the data records once written, do they ever need to be updated or deleted? Are there sensitive identifiers that will not need to be written to the data store? And are there entities with write access to the database that may have a hard time deciding who should be in control of the data store? And then lastly, do you want, a tamper-proof log of everything that writes to a certain data store? And if those questions are all in the ballpark of yes, then I think blockchain could be a solution to your digital twin ecosystem. So to conclude, I don't necessarily think blockchain will help digital twins innovate faster, but I do think, and I'm bullish on the enhanced trust and security that'll implement and tie in with your digital twin solution.
So maybe I can just add real quick, Farsad, to what you just said, because I fully agree with it, right? I don't think that it is a solution for every case. As you mentioned, blockchain is not a great database. It's not. However, what I'm thinking is, is when we're talking about the low carbon economy and the lower carbon future, right? So again, back to my point initially, maybe not for maintenance and operations because that's internal data, right? The data that we get from a pump and whatnot, that probably is not best to be stored in a blockchain. But when we're looking at different players, when we're looking at the whole carbon value chain, I do think that blockchain will play a huge part in that. And I think that the digital twins that come into play in that space will require a better transparency and better accountability in the future.
Yeah, I would.
Yeah, I agree with this point, Andrea. Thanks for building for the carbon emissions and trading, whatnot, what is going on today for the net zero target. Blockchain is the key. The reason is we can build a sustainable value chain. It's not just about one company. We want to be effective to meet the Paris Agreement. The complete value chain partners has to be onboarded. I can share
Yeah,
if it's okay. Yeah. The topic I think here is, if you don't mind, I'll share the uh, share. Okay. Uh, Here is the. I think we're talking about the security. Not wrong, right? Ensuring safe and security with the blockchain, that is the key, right? We have securities for the IoT devices from the cloud, and then whether the data will be in transit or it will be in at rest. If you look at the left hand side, we have implemented the solution for gas station, and then the auto consumer, and they will be a transportation also. The trucks, meaning, so we have devices in the all three places. So one is in gas stations. Gas stations have multiple dashboards, sorry, multiple tanks, and there's auto consumer. You might have only one tank. Then the transporter, you might have also have the tanks. So key here is if you want to have a IoT device, then you need to have some kind of gauges. Then we need to take that data into for various reasons. But how do you protect that data? IoT device. There are various technologies here. There's HTTPS, X509. Then the of course SHA belongs to my also belongs to the blockchain. But where we can use the blockchain here, by providing the digital certificate, creating the digital certificate and certificate authority, saying that use this blockchain. You define, hey, if somebody want to open the doors for the blockchain devices or IoT data, so blockchain comes into picture, defining the endorsement policy. These are the parties they need to use the data in
Thank
the
you,
supply
Krishna.
chain. Welcome.
Thank you. So, Binu, you want to go ahead?
Yeah, I was just going to echo what Farzad and Andrea said. Blockchain is valuable when you have to deal with a trust or verifiability issue, and sustainability. I completely agree. I mean that's one of the areas where, especially when you're going to have to show compliance, where there's an aspect of trust, that'll be the sort of area where I think it plays well. When it comes to IoT, I frankly think, I mean, I very much echo Farzad here, is that use the tool that it makes most sense. When you're dealing with IoT, you're talking about enormous volumes of transactions, right? Billions, trillions of rows. At that volume, the energy overhead of using blockchain is extremely high. In the current technology, now remember, technology will improve. I fully expect that in the next few years, the technology will change. But today, it's fairly slow technology. The last piece of it is that when you're doing something about trust or verifiability, the data itself need to be worth trusting. Frankly, today, the number of sensors that you'll have that have issues, right? You might have a particular sensor that is giving you invalid data. And today, you have to assume that that is the case when you're dealing with that. So you actually need algorithms to go in and determine, do these sensors, the readings from these sensors make sense? Because if you're trying to deal with this at scale, and this is actually one of the benefits of using AI at scale, is that AI is actually fairly resilient at dealing with some sensors that might be off, versus others, right? So you have to assume that some of the data you're getting in is garbage to begin with. In that kind of context, attempting to put in something like blockchain, may not give you what you're looking for.
Thank you, Binu, for the comments, and thank you all. We have a couple of questions actually. Let me quickly check if we have additional. Okay, I guess we have two questions. First one, by the way, I just copied in the chat. You can see that too. The first one: how do you solve the delay in accessing data or the twin if on the blockchain? As it has been said, blockchain is a poor database. Who wants to answer this? Who said poor poor database? Then whoever said poor database, please explain it.
I think that was
Well,
Farzad.
I do think it's a poor database. I don't know how to solve the delay. I'm not a software expert. Yeah.
At least in my perspective, I think that's one where the technology has to improve. And there is a tremendous amount of research development going into accelerating blockchain. If you look at Ether, for example, I believe the transaction limit is about 15 per second worldwide. Now, that will change dramatically over time. But I think the question itself may be self-answering. It's today you don't use it for high volume database transactions. You focus on things where trust and verifiability are important, and in that context, it's useful today, and it will improve over the next few years.
Yeah, let
Good
me take
point.
that question. Let me answer. Blockchain is not a pool database. Blockchain is a specialized database. We have to take care about what information we need to store on the blockchain and when we need to when we need to store the data. So it is basically for events, right? For example, take for example something happened on the asset when it happened, and PO is rise, for example, or something happened on the asset. That is the information we need to store on the blockchain. Then we don't store every in the PO. We have multiple attributes, including the documentation, bill of lading. We don't store that data. We shouldn't store that data in the blockchain. The data we have to store on the documents, everything we need to store on the off chain. Then we have to create the link. So we have to minimize the creating number of fields on the blockchain.
Yes. Thank you, Krishna. I guess
Thank you.
this is an ongoing research and integration of blockchain to the oil and gas to cope with some issues like data trustworthy, accountability, and then transparency, I guess. We have one
Yeah,
last
when we get
question.
transparency, yeah, there's 100%. There's a misconception on the transparency. Yes, we need to implement 100% transparency and the agreed partners. Example, right? Then we have to do the confidentiality and data privacy between agreed partners. If I'm working with my partner, I don't want to share my data with my competitor, for example. Then we need to implement that. We need to take all this into consideration when writing smart contracts in the blockchain.
Okay.
All
So
these
yeah,
features are available in.
yeah. Thank you, Krishna, I guess, for the timekeeping. Let's move to the next question. But before, we have another question from the participants, not about blockchain, but about the facilities digital twin. The question is this: could panelists discuss about the challenges on building a production facilities digital twin in terms of training new predictive models, ensure twin reliability, manage models versioning, run hundreds of models in an automated and real-time way? How to orchestrate it and manage hybrid twins, that is physics and data-driven based. Who wants to answer?
I can take a stab at it.
Yeah, go ahead, Vinny.
This is I think this is something that has been solved. You do have to take into account all of the different pieces that flow into the process that you mentioned. First thing starts from data. Um, you're typically getting data from multiple facilities and from multiple sources. OSI Pi historians, I think we've all talked about that as a major source. But that's not the only one. You might be getting data from specific machines, SCADA systems, and so on. What I've seen as most effective is first building a data lake that will act as a collector for all of these items. You need to get into a place that can be accessed by the model. So number one, ensure that you have your data infrastructure. Number two, I think this is very important. Don't worry excessively about structuring and cleaning all of the data up front. That is always an ongoing process. But one of the things I've seen as a challenge is that people attempt to try and get everything right in the beginning. It's always an ongoing journey. So start with what you have. Then in terms of orchestrating the models, then it's really about running data pipelines and ML pipelines at scale. So you've got to make sure that you have all of that infrastructure. And that can be fairly challenging because really when you want to make this thing cost effective, you also need to get this to be self-service enough that, it's one thing dealing with one model, 10 model, 100 models. When you're dealing with thousands or tens of thousands or hundreds of thousands of models, then you really need to make sure that the infrastructure is self-service enough that a maintenance engineer or a process engineer can go in, load in the system that they want to have modeled, and have the system automatically train. So again, all of these things have been solved, but you do need to make sure that you consider all of these factors as you put into it. The last bit that I would talk about what I see on the question is how to manage hybrid twins, physics, and data-driven models. The physics models can be extremely accurate. The challenge is calibration. So what we've seen as most effective is using the models, the data pipelines, to really feed into the physics models. And you do one of two things. One, relatively simple physics models are very easy to merge in with an AI ML model. The more complex simulation type models are also important, but you use them judiciously. You use them to generate either proxy models, because the physics model itself can be fairly expensive to run, and you ensure that you have calibration needed. What we find is extremely useful is using what we call a foresight insight model. So you get predictions from the AI ML based models, but once you find that you have an alert, for example, the AI ML model might raise an anomaly, for example. But then what you want to do is use the physics tools to go in and dig into it in more deeply, and then say, run the full-blown diagnostic to find out what's going on. So you want to make sure that you're combining these things in the appropriate way. But the good thing about this is that this is, I think, largely, considered something that has now been solved, and we see that with many of the partners and customers that we work with.
Good point, Benio. I guess cloud has been utilized to orchestrate both training and inference data pipelines for multimodal scenarios, I guess, too. Let's jump into the next discussion point. The next one is the data gaps. How to fill the data gaps. Focus on cognitive computing and understanding the true value of machine learning. And let's start with Andrea.
Yeah, I actually, when you say data gaps, for me, the problem is not that we don't have enough data, because we have plenty of data. The problem is how do we turn that data into insights, right? So I think that's really where we focus. So when I'm looking at opportunities, I'm more than finding, because data, you can get it from sensors, you can get it from, from the original drawings, from the digital twins and whatnot. But what do you do with that is the real question. And how do you train these models, and how do you get actual, alerts that are meaningful? So I think that's really where the work needs to be done.
Yes.
If I could
Pedro?
add to that,
Yeah.
yeah, absolutely agree with that. So it is a fact that especially the volume of unstructured data is just massive and it's increasing. All sorts of logs being recorded everywhere. So the challenge is really how to get information out of these. So that, in my view, what we want really to do here, connecting with the cognitive computing, is really how do we expand the boundaries of human cognition? How do we help an operator in the smart room, in the platform, take the right decision? So at the core of this, in my view, we are trying to leverage the knowledge, the way the humans, the operators, record and communicate human language. In particular, text is a big challenge. So we expand this knowledge base that the operators have by giving them access to deeper layers of the information that has been processed, synthesized appropriately, so that the best decision can be made at each point in time. So this also makes the best use of the operators, because we help them doing that by looking at the variety of indicators they may need to look at and take the decisions according to those signals. One of the things that we are starting to explore is to give our users access to human readable explanations and the ability to interact directly with the models using natural human language. And this is especially important for those cases where the failure modes are unknown. So it's something that we cannot characterize on some kind of operating envelope or operating mode, and something completely new that needs a little bit of exploration. So we are building this interactivity so that the users can use their natural human language to guide them through, so they can take the best decision. And we are making that as part of our digital offering to them, together with the anomaly detection, using some of the technologies that we are talking about here.
Great point, Pedro. Farzad, do you have things to add?
Yeah, I'll just keep it real simple. I think Andrea and Pedro hit it on the spot. I think it's really, how do you turn these data into insights, and how do you know what an insight looks like? And to me, my biggest lesson learned is building machine learning models sometimes really just for the sake of building machine learning models. And are we taking a human-centered approach to building these digital solutions? Are we empathizing with the operators, with the facilities engineers, design engineers, whoever the end user of a machine learning model may be? Are we disrupting their workflow? Are we adding another tool in their toolbox for them? Are we automating some sort of process? I think answering those questions kind of within the define and empathizing stage of the design thinking process, I think is so important, even when it comes to cognitive computing and building machine learning models. So we talk about data, we have tons of data, the data is there. It's up to us on how we can use this data to build really effective insights that ultimately, make our end users happy, make them, valued with the work that they're doing, make their lives easier, make them feel fulfilled and happy. Hey, this machine learning model just made my life a whole bunch easier. I think that's what it's really all about in terms of trying to fill in the data gaps, just make the end user, make the customer happy.
Thank you, Farzad. Do you have any examples to share?
Yeah, I think maybe echoing a little bit about what Andreas said. Yeah, when you start looking at data gaps, there's really two issues you deal with. One is, do you have the right sensors? These days, especially in oil and gas, I mean, I think other industries are worse off, but in oil and gas, you're fairly well censored. Now, that said, one of the good things about the techniques that are available right now is that you can create models even with missing data. Obviously, the fidelity of that model might be lower, but you might get some interesting insights. I mean, we did, for example, with the US Air Force, where because they were very old planes and did not actually have sensors, we were actually using NLP techniques on maintenance logs, and that gave you some insights. Again, obviously nowhere near as good as you would be if you did have the sensors, but you can extract valuable information out of that. So that's one part of the dimension. And I think the other part is the aspect of if individual sensors are giving you invalid data. And I think we talked about that a little bit as well. So you have techniques for both of these. The question is, what is the situation you're in, and what are you trying to achieve?
Thank you, Binu. Krishna, do you have things to add to?
I'll make it very short. Data is fundamental, and oil and gas industry is the father of the big data, right? So we need that data for quick decision making for the stakeholders, investors, employees, whatnot in the supply chain, and that data is sometimes available in the different sources. We have the technologies to take that data and give it to the end users who according to their need. But it is a key.
Yes. Thank you. Great discussion. I guess if you think artificial intelligence and overarching theme, I guess machine learning is one part of it, which artificial intelligence has some reasoning too, causal reasoning, for example. I think get this into our machine learning models is very important. We talk about subject matter expertise and years of experience how to incorporate this. One thing that we are also working on to utilize physics informed machine learning models where we know the governing equations to simplify and have more accurate solutions for a machine learning model, for example. Those are all good discussion points. Let me quickly check if we have any question from the audience. No, we don't have. Okay, the fourth item that we are going to discuss today is building a blockchain and IoT stuff, building a decentralized digital community through blockchain and IoT. Andrea, you want to go first?
I don't want to go first.
I can go.
I can go first. Yeah, I can go first. And also I
Okay.
can share if it is okay. Yeah, I can go. Let me share my screen.
Krishna, I think that causes a problem when you share a screen. So they
Oh,
told us not to share a screen. So sorry about that. If
okay.
you
So building, no problem. Building the decentralized community is nothing but again is a collaboration for the all the supply chain partners. With the blockchain, if you want to build a community, you need to start with uh, you need to engaging with the partners. So that the all the partners will decide what information to be stored. Basically, example of the decentralized community is nothing but every participant in the application will have their own node. The node can be deployed on their own preferred premises. It could be on premises, it could be in the cloud. But with blockchain, if you want to build a decentralized community, then we need to start engaging all the parties who are going to be part of the initiative for the in the drilling operation, for example, start with upstream industry, suppliers, service company, manufacturers, and we need to partner with them. That's my since I cannot share the my screen, but that is starting point. Again, not all data we need to put in the blockchain. There's a misconception of the blockchain. We need to sit down and go to the define what elements of data needs to be inserted into blockchain and with what partners.
If I could add to that, so we're talking about this system of interconnected devices, right? So the amount of data they produce is huge, and we are all working in places that have some sort of centralized cloud technology, um, and that doesn't come with that doesn't come without any issues. So I think there are some issues that need to be addressed in order to move further and really talk about the digital community being built. Um, so there are some bottlenecks, for example, with existing cloud IT systems, like in terms of scalability, in terms of the coordination between different systems. So so there are some arguments that in order to scale, you need to process data locally and share resources between devices. So I think we need to be careful in terms of not sometimes moving too fast into try to build something so grand without first resolving some of these technical challenges. Also, things around security, for example. Um, so that there is, in many times, critical infrastructure between these connected IoT devices. Um, so having a decentralized approach could help solve of these issues, but I don't think it's the answer to everything. I'll just say that I think we need to move carefully in this space so that we integrate things properly with the existing IT systems, and only if those systems, decentralized systems, do not solve the problems that that are likely to appear, then needs to start thinking what else can we do to solve it. Also thinking, of course, about the costs and enabling really the balancing of resources uh, between machines. So I think we need to. I think it's we're allowed to dream and to think about potential solutions, but I think we also need to be careful on how we integrate these with existing systems.
Great point, Pedro. Who wants to go next?
I can provide one perspective, maybe not on the blockchain piece because I think we all talked about that. But when it comes to decentralized communities, I think the technology is less important, and it's really more about how the rollout of these tools is handled. In our experience, especially at scale, you absolutely need to have self-service capabilities. I take the example of what we do. We all do these days with Zoom or Microsoft Teams. The tooling is provided by a vendor, but we all form different communities and groups and share information. And as long as the technology enables that, then you have a lot of, I think, generation from that community. So self-service is absolutely critical. I don't think we need to worry as much about the technology as long as it enables what you need it to do.
Thank you, Bino. Anybody else wants to share? Or we have a question from the audience. This question about the limited data, actually. Uh, the participant asks, for specific applications such as subsea, where there is limited data, fewer projects, and very limited accessibility, will the ML approach work, or should the focus be on knowledge-based Bayesian type approaches?
That's a good question. I can go first on this one actually,
Yes.
because it's a topic that is very dear to my heart. I used to work as a subsea engineer, and I worked for many years on electrification, right? So I think you are correct, and most people don't realize how all the technologies we use subsea are. Um, and by going electric, we could actually access tons of data, right? So when you go from hydraulic actuators to electric actuators, you actually get a lot of data on your system. Then you can start using, a more sophisticated approach. So I do feel like this is work that has been done for at least 20 years now. And I hope that that's the future, so we can actually get more control, better reliability, and more data. Um, but maybe I'll pass it over to others to comment on the type of different approaches when you don't have enough data. I do think that there are hybrid models and things that you can do in order to recreate, as Binu was saying, when you don't have all the sensors that you need.
Yes. So when you don't have a lot of data, I guess it is good to have some uncertainties, right, around the data that you have, limited data that you have. And this Bayesian type approaches has been utilized, and it is pretty much getting, in terms of modeling approaches, getting very mature. There are a lot of resources now that uses Bayesian methods, uh, Monte Carlo simulations, Bayesian neural networks. Those kind of things has been highly utilized actually. Anybody else who wants to answer this question?
Yeah, and only one point I want to add: if you don't have the data, then you need to come up with some proxy data for that, because modeling for ML particularly without data, it's very hard to predict. It won't give the result. So real data, if you don't have, then at least some kind of proxy data we have to have. I recommend.
Yes. This has been utilized in subsurface too, right? For reservoir characterization, they use proxy modeling approaches. Anybody else wants to talk about limited data? I guess this is also an important question and important discussion topic too. Okay.
Yeah, that echo what Andrew and Krishna said is that um, ML does require a certain amount of data, and you can either look at proxy techniques, as Krishna mentioned, or I mean, and I think the question also was about knowledge bases and so on. So if you have an expert system, if you have heuristics that you can use, Bayesian approaches, that might work. With ML, our general rule of thumb is that if you're using a supervised model, you need at least a few hundred events. If you're talking unsupervised techniques, anomaly detection, then you need enough history where you can actually model from that. That may not need to be too long, but at least enough history that where the sort of patterns that you're looking for, that they will occur. So yes, I mean, I think it's a combination of picking the right tools for the right job.
Yes. We have actually two more questions from the audience. The first question is that about digital twin. When do you think we should start the development of digital twin? So when is a good time?
Um, yeah, shall I take?
Yes, sure, sure, sure.
Okay. See, the when should we use the blockchain for sharing of digital twins? And as long as you are dealing with minimum of two parties, and those parties external party, then we should use the blockchain. Again, we have a sharing of data is a you have issue of sharing of data, then we should use the blockchain. I mean, there is next topic also. There is maximizing the simultaneous technologies. I would say maximizing multiple technologies is the right word, and all these technologies what we're talking today: blockchain, IoT, RPA, machine learning, and the metaverse, which VR, XR, whatnot, cloud. They need not be start at the same time. Based upon the use case, you can start with either blockchain is the first building point, starting point. The reason is blockchain is a database. It's a centralized database. So digital data, nothing can be produced. So I would start with the identifying the right use case with the two parties, your external parties. There's no point in using blockchain for internal, only for internal parties, which are already centralized applications, which are already client server applications already serving your need. But if you're having issue with the external parties, start with the blockchain as a database. Then defining the what information should be shared between those parties is another important topic.
Yeah. So the first question was that when do you think we should start the development of digital twin? And I guess Krishna, you answered the second question, which is the question is that how do you see the use of blockchain sharing digital twins among companies or even industries, preserving data ownership, evolving models accuracy, and building new business models for early adopters? So you guys can answer these two questions in your answer actually. Who wants to share opinion? Is there a good time to start digital twin?
As soon as possible.
Yeah,
We
I
are
think
already in.
I
I
would
guess there's
say
nothing to avoid.
you have the any issue which is today you have a dealing that issue in the real time. The physical asset you are dealing, then represent that physical asset using the virtual with the digital twins using the metaverse, for example, representing that using the virtual asset uh, uh, virtualization technique. Then that is the starting point. Take the predictive maintenance, for example, of the asset, and today that is the issue, and you need to start implementing these digital twins for that asset. The asset is a key point today.
Yeah, and will maybe Shell will be interested in sharing their digital twin or blockchain technology with Total or Chevron. Is it something like I understand from the second question? I guess we have some NOJV assets where there are multiple operators are in the game and they share a lot of data within themselves. But what do you think about those kind of question?
Yeah, so
I
I'll
don't
give
think that operators. Sorry, go ahead, Fasad. Go
no,
ahead.
no, no, you first. You first.
Go ahead.
I'm
I was
talking
just
way
gonna
too.
say I don't think that operators actually share a lot of data. It's quite the opposite. We're very protective of our data because uh, if you ask me, data is the new oil, right? So having access to somebody's data is like having access to all of their information. So um, I think it's gonna be difficult to say, oh yeah, let's create something where Chevron and Total and Shell can actually collaborate, because then we would lose our competitive advantage.
Yeah,
Yeah,
I think
yeah. So I think that's a fair answer. I'll give a quick shameless plug. There's a nonprofit organization that I'm a technical representative for called Blockchain for Energy, and so there's a lot of different operators from Chevron, Exxon, ConocoPhillips, Pioneer, and a few others that partner with this organization essentially to prove out. Well, I guess now it's all kind of already proven, but now it's actually taking use cases from different companies where they think we could actually leverage blockchain or distributed ledger technology to maximize efficiencies or reduce cost or improve timelines and essentially just drive industry transformation. And so I think particularly around the blockchain ecosystem where we all kind of agreed that, anytime there's an issue of trust or security and there's multiple parties involved that need a shared ownership of data, I think a consortium like that effort is a really good consortium or hybrid blockchain to drive some of these collaborations and solutions. And so, obviously, there's a competitive performance perspective and competitive advantage from of Chevron keeping our solutions, Shell keeping their solutions. But in order for net zero, for example, in order to achieve some of the net zero and some of these other kind of performance and strategic goals, the way we get there is by working together, and whether that's sharing of solutions or at conferences like this or webinars like this where we throw thought leadership to each other, that diffusion of innovation is, I think, what that real value add and per shared purpose really which is kind of why we're all on this webinar together. And so I think, to your question, I think the sharing of individual solutions that may not be, I guess, desirable by a lot of different parties. But I think the thought leadership and the art of the possible and the future vision state of what we want our industry to look like and how technology can shape that industry, I think that's the real answer.
Yeah,
Yeah, I think from a sharing perspective, um, I've seen two models. One is the open model, right? So the groups like Farzad mentioned, the OSDU and the upstream, where you have sample data sets, you have generally accepted techniques, and so I think there's going to be a combination of open groups. The other thing I've also seen is licensing of technology, essentially selling applications. So Shell is doing this, by the way, for their control valves module. LyondellBasell is looking at doing that for things like rail car optimization. So I do think that we're going to have this kind of dual model of where you have the general infrastructure that is common and open, And then you have specific models that where I would say more the algorithms rather than the data are really sold as applications. The data itself, I'd echo Andrea. I think that that's, other than sample data sets, sanitized for use, I see very little actual data sharing going on. And I'm not sure it's critical just yet. I think we're in a model that's very different from, say, what Facebook or Google would do with like trying to do ML on photos. The focus is much more on understanding the appropriate technique for the problem, and then sharing the techniques versus the data or the individual models themselves.
Great point. Yeah, another question about sharing. Does it make sense to compete on everything? Should operators not collaborate on aspects such as, for example, safety? So I think you guys mentioned, Farzad, also you mentioned about sharing. Slowly but surely, hopefully we will get there to reach some common goals like low carbon and stuff, as you guys mentioned.
Maybe I can answer this
Yeah, go
question.
ahead.
Because I work on the venture side of the business, right? I don't work in the operational side. And I think on our side, there's definitely a much more collaborative environment. We co-invest with Total, with Chevron, with BP, with all of our competitors, basically, as well as with financial investors. And the thing is, there are problems that we're trying to solve that are too big for one company to solve them, right? So perhaps the area of safety is one, but when we look at things like hydrogen, like carbon capture, like the future of the lower carbon that I keep talking about, I think these are areas where nobody has actually figured it out, where we need a lot of collaboration, and I do see that in the venture space. But when it comes to data, specific data to operations, there's still a level of we don't want others to know exactly how the sausage is made.
Yeah, you're right. Pedro, do you have anything? I thought,
No,
do
no,
you have anything to say?
I agree with all that. Yeah, that's the current status. I can only hope that in some of these key, perhaps even ethical projects like safety, we can collaborate a bit more. Yes.
Yeah, new energies is some area that oil and gas companies are not experienced with, and they need other, resourcing outside this venture capitals. Those projects, I guess, uh, will be they will be consumed by these oil and gas companies to know better about this new energy opportunities. Um, okay, I guess we have maybe 10 minutes. Okay. So any final thoughts? Let's do a little bit round about challenges and opportunities offered. Just
Yeah,
15,
I
20
would say
seconds.
like coming back to some of the points that were already made about the users first and building solutions that will really make a difference and help them take a decision. I don't think we should restrict ourselves on technology X or Y. I just think that should see what's best for the job. And if we have that technology already in house and it solves the problem that we need to solve, and we can take the right decision at the right time, should just go for it. Not really reinvent the wheel and try to implement a new technology just for the sake of it. At the same time, I do understand that we are building products not just for tomorrow or next week, but they have some longevity. So we need to think about how these things are going to be augmented and maintained in the future, and some of these technologies will come into play. So I think it is important to keep track of what might be needed, especially if there are data gaps and we need to fill some of those gaps with IoT devices, let's say. But I think we should always choose the tool that does the job for the users and allows them to take the right decision.
Great.
Yeah.
Yeah.
uh,
Hey,
I think
Mustafa, yeah, I think, sorry. Sorry, Andrea.
No, no, there's a little bit of a lag. I apologize. But I do think that what Pedro said resonates a lot with me. I think a digital twin should only be as complex and large as it is required to achieve the desired business outcomes, right? We don't want to over engineer stuff and overcomplicate stuff again with blockchain. Like you don't want to use blockchain when it's not absolutely needed. We need to ensure that we have reliable access to clean, accurate, consistent data. Otherwise, we're not going to be able to really deploy all these digital initiatives. And I will close by saying that the biggest challenge I see is that our industry actually has very few mature data standards. Um, and I'll just leave it at that.
Okay. Thank you, Andrea. So we have a couple of minutes left. So Krishna, you were saying something? Last
Yeah,
comments?
so to add to digital twins, for example, scope 3 emissions are very complex. Today, those are belongs to supply chain partners. That is another area where you may have to think of using digital twins. So that the simulation to start with, for example, for the methane emissions, that is very complex, very hard to capture to identify these super emitters and the hotspots.
Yeah, thank you. Binu, do you have anything to
Yeah,
capture?
I think to close off, and it's been a great discussion, by the way. I think this is some very interesting topics. The I think the key thing for real adoption is a laser focus on the business value. In the end, when you're trying to do this and rolling it out at scale, you need to have multiple stakeholders participate. So there'll be a data science community, R&D community. There's the business. There's the sites. There's the operators. And if you really want to have adoption, beyond it being a theoretical or nice to have, you need buy-in from all of these stakeholders. And so the number one driver that helps with that is very clear business value metrics and monitoring of that. And the other thing that I've also seen in our experience is really thinking about how you make this accessible to the end user. That might include partly a tool that is easy to use, but may also include having services organizations that can support someone at a site. I mean, someone at a site is always extremely busy. You put another tool in front of them. I think Pedro talked about it. If they don't use it, all of this technology is useless. So, if I could have a call to action, it's really look at business value and how once you roll it out at scale, you're going to ensure that it's actually used.
Great points. Farzad, do you have last comments?
Yeah, I'll keep it really short. I think we all know the digital twin market is only just exponentially growing. I think it's estimated to be 50 billion kind of within the next 4 to 5 years. Just like Binu said, it's probably the most difficult technology to implement at scale while also having the highest impact to our operations. And it's all about making data valuable. So to close off, there was a question. I'll revert back to the question: when should we start our digital twin development? The answer is right now. Whatever stage you're at, you have to crawl before you can run. If that's just spinning up your cloud infrastructure or growing your organizational capability in data science and machine learning, that's a great start. But to close off, incorporate digital twin into your digital strategy, or you will get left behind.
Thank you
Well
very
said.
much for those comments too. Really, it was a very, very interesting discussion, a lot of insights and knowledge sharing between operators and service companies in digital space. Hope the participants enjoy this discussion, and this discussion will never end here, so it will continue.